Hello YouTube. I am going to give it another minute or so to see if an audience will come in, but today we will be talking about, well, first off I'm going to talk about the program you see on the screen now. That is a fairly new project I've been working on. It's something I've taken a stab at before, but I needed to step back and think about for a while. But now um, I am looking at it again. So here I will be talking about what changes I've made to the program as a whole, and how those changes, how I hope those changes will affect the program. So I'll wait around for a bit, but we will be getting into that momentarily. If anyone in the chat can give me a heads up of whether you're getting something through, this new program I'm running is taking up literally all of the CPU on my computer at the moment, so it seems that the stream isn't really responding, and I'm not sure if it's getting through to you guys. So if I could just get a notification from anyone whether or not whether or not there's an output to the screen at the moment, or is it just buffering? Okay, it seems that the program is being a little too much for my computer. You may be getting bits and pieces of what's happening here, but I'll just start explaining, because it seems like we won't be able to get very good quality at the moment on the stream. Okay, so this project is what I like to call Hivemind. And the basis for the project was to see if the AI I have could handle a large number of variables being taken in as inputs. Basically, so if you can imagine the hypothetical robot model, then this would be a robot that has, let's say, 200 sensors, and it has to make decisions it has to make decisions about what to do, what's the next move, based off of the information coming in from all of those sensors. But the first time I ran this version of the program, I noticed that it was, for one, it's obviously taking up a lot of CPU, because to process all of those inputs every single iteration takes a lot of computing power. But also, in general, the program was running fairly slow in how it in its progression. So even when it was able to go through a generation, there wasn't much progress on each generation, showing that the AI in its previous state was not very apt in sorting through the variables to find which ones were important for the current task at hand. And I'm sure if I gave it enough time, it would eventually sort through those different variables. But to have it sort through and create a solution or a relatively reasonable program as a best program, I would have to have it. It would have to take a lot of time, and so what I set out to do was to cut that time down. So the task for this Hivemind project is, as you can, or you may be able to see on the screen, there are 15 dots in this black square, all moving at a constant speed in a random direction, and when they hit a wall, they bounce elastically, so they they reflect the angle, and they keep that constant velocity. So the goal of this program, which you might be able to take some shots at from the title of it, Hivemind, is for the program to direct these dots so that they don't intersect. So anytime you'll see that the score will start at 10,000 to begin an iteration of the child program, and when any of the dots cross over, that score goes down dramatically. This is because I made it so that the score is based off of a fitness test, which is 10,000 divided by 1 plus the number of collisions, 1 plus, because if there are no collisions, then you can't divide by 0, the program would crash, so it has to be 1 plus, but that's minor. So what happens is, so that every time a dot runs into another one, it is considered a collision, although I don't have it so that they bounce off of each other, they just run through each other. It's a lot easier to process, and it still proves the point. So what the problem is, and you may be thinking, where's all the variables here? Yeah, there's the variables for these 15 dots, but that can't be too much. But what I'm doing to simulate having a lot of sensors is I'm feeding in 200 different variables, and only 30 of them correspond to these dots on the screen. So what the program is trying to do, what the AI is trying to do, is sort through those 200 variables and give directions based off of the variables that are specific to these 15 red dots. Well, that's not necessarily what it's trying to do, but that's what I would hope it will do. What you will see when watching some of these iterations, if they are visible on the screen, is that some of these dots are not moving in straight lines, but instead are moving in more circular patterns. And this is because of, like I said earlier, the AI can give directions to change, for these dots to change directions. And in the early states, the dots, the directions that it gives tend to be constant. So you will see a lot of programs causing the dots here to just go in circles, simply. But what have I done to make this program better so that it can have more productivity? So what I did was I applied a filter to the variables. So in a normal case without this filter, the AI has a selection of 200 different input variables to look at and make decisions based off of. But when with the filter on, the AI can only apply the AI can only apply mutations to have decisions that are based off of variables that are changing often. So what's happening is the variables that the AI are taking in are the x and y coordinates of these dots on the screen, and so there's 200 different numbers, and 30 of them are the x and y coordinates of these 15 red dots. So the other numbers are simply just fuzz numbers, so they're just distractors, and those distractors don't change, they stay constant. So what the filter will hopefully do is, after the first few generations, possibly even, oh, actually right there you can see one of them circling and bouncing around in a circular manner. So what the filter is hopefully going to do is take the what am I looking for? Oh, so it looks at all of the variables it's trying to apply, and if those new variables, and I like I said earlier, these are only when new decisions are mutated. When these new mutations are being added into the generation, they go through a check system to see if the variable that it is being mutated to base decisions off of has changed a lot recently, or has changed recently. So when it goes through this process, it then it keeps trying different mutations until it finds one where the variable matters, and that matters if it is changing constantly, because you can think of it as maybe like gravity. If gravity is a constant force, so you don't, yes, you have to apply things for gravity, but you don't have to make split-second decisions based off of how powerful gravity is, because gravity is constant here on the planet, or relatively constant. It's I mean, as you get higher up, it does technically get slightly smaller, or slightly lesser, but it's still within our sense of feeling negligible indifference. So that's basically the concept, is that only the variables that are changing are being considered for split-second decisions, and hopefully what we will see if this program is run to exhaustion is that the AI will start to give directions so that these dots don't collide. And whether or not that will happen is up to the statistics of the AI, and I will be running this off screen a little bit, considering how slow it runs already, but I will update the live stream in the next stream on the progress of this program. But that's basically the project I've been working on at the moment, and with that I will play a short ad and then move on to the bulk of this stream, which I will be talking about coding in general and the basic concepts behind it. Because a lot of people tend to see coding as magical, and to be honest, it's not really that magical. It's just a grouping. It's just a combination of different mechanisms, and so stick around through the ad, and I will get into that in a minute. For those of you watching on YouTube later, I am sorry for the silence, but it is easier to transition through an ad. Alright, I think the stream is back, so I will get into the conversation about I'll get into the conversation about coding in general. So, basically what I'm going to get at is that coding is basically, so writing a program is just finding the path to get to the outcome you want. So I'm going to start with a metaphor. So let's think of a system. So let's say you want to irrigate to a city, and you know where you're starting and you know where you want to end, and all you have is two different types of pipes. So you have the straight pipes and you have the elbow joint pipes. Well, if you have obviously in programming there isn't really a limit on how many pieces you can use, but you want to get to from point A to point B using the least amount of pieces possible. So you would take the engineering process, you can take out a piece of paper, map out point A and point B, and then find the quickest path using those pieces, and then so then when you map that out, then when you actually build it, the water can flow from point A to point B, and that city can have water. So coding is not too different from that in a general scale. In a micro scale, there are a lot of intricacies, but today I'll only be talking about the general overarching principles of programming. And I see that there's a question, but I will answer the questions after this section. So like I said, in the metaphor, there's different pieces and parts, and you use those to get to your designated end goal. And so in programming, those pieces and parts are if statements and loops, and there are other different pieces that as you learn programming you will be able to apply, but the general mechanisms that are used to get from point A to point B, for say, are if statements and loops. And so first off, I'll talk about if statements. If statements are basically like forks in the road. So so it's sort of like if you have a sentence that starts with if. So you say, if this happens, do this. And so that's conditional. So what happens is when you have an if statement in a program, the program goes through, it sees the initial if statement, and it says, so let's say if the sky is blue, then dance, I don't know. So it will go through, it'll see if the sky is blue, so then it checks if the sky is blue, so then it dances. So, and that's a silly example, but I think it gets the point. But that's the general idea of if statements. So then the next piece is loops. So loops are exactly what you would think they are. Basically, when the program gets to a loop, it does the one thing. It does what you have in the loop, and then it loops back to the start, and it does it again, and it keeps going until it hits a point where you tell it to stop. There are two different types of loops. There are for loops and while loops, but if you ask me, for loops are basically just overrated while loops. They're kind of, it's not like they're not useful. I definitely use them a lot. It's just that while loops are the more generalized term are the more generalized mechanism. So what a while loop is basically an if statement that starts it checks every time it goes through the loop. So what happens is you have the while statement. So you have, let's say in our situation, is the sky blue? So if it goes and it hits the while loop and it says, is the sky blue? If the sky is blue, then it goes into the loop, and then it does whatever you have in the loop, and it loops back around to the top, and it rechecks the if statement. And if the sky is still blue, which I would assume it is, then it would go through that loop again, and it would keep going through that loop until the if statement is no longer correct. So, or the if statement no longer checks out. So it goes in and says, and let's say it was nighttime and the sky is no longer blue, then that it would say, oh, the sky isn't blue, so now I'm going to skip over what's in the loop and break out of the loop and move on in the program. And so the difference with for loops is that instead of setting a specific condition for going back into the loop, the for loop you give it an amount of times you want it to go around the loop. So if you tell a for loop that you want it to go around 25 times, then it will hit the for loop. It won't even question whether it needs to get into it, and it'll do whatever is in the for loop, whatever functions you have in the for loop, and then it will come back to the top. It will add to the counter. So the counter in programming usually starts at 0, just because that's the way computers think. So it will start at 0 and then go 1, 2, 3. Or if you tell it to count by a different amount of numbers each time, then that's your decision. But so it goes into the for loop, and then so it reads through the functions in the for loop and performs the actions you tell it to, and it comes back to the top, and so it adds to the counter, and then once the counter hits 25, which is what you said, how long you wanted the for loop to run, then it breaks and it moves down into the rest of the program. And these are really useful when something uses a specific is used a specific number of times. So let's say you wanted to print something out to the screen 25 times, then you can just simply put it in a for loop that is labeled to run 25 times, and the for loop will run that print function 25 times. So, like I said, those three, but technically just two different mechanisms are what make up the majority of all programs. So the complex part and the fun part for me is finding the different combinations and finding the creative ways to use those mechanisms to get what you want out of a program. So you can start with something simple, like trying to do a math, because that's what computers are good at. They're good at math. They're basically just really big calculators that are a little smarter. So what you can do is, so computers, if you give them an equation, they'll solve it. That's a basis in programming. Well, not like a variable equation, but like if you put 2 plus 2 equals something, and then you print out the answer, then it'll tell you 4. So if you need to say, let's say you wanted to print out the number 31 for some reason, but you didn't want to just say print 31, you wanted to get there by using these if statements and loops, then well, you can use loops by saying, you could say, if the well, it'd be kind of weird if you already knew the answer and you were using it to find the answer, but you could say if the you could say that a variable starts at 0, and then if it is less than 30, then it goes into a while loop and it adds 10, and so it'll add 10, and then so now it would be 10. So when it comes back up to the top and checks, 10 is still less than 30, so it'll go back into the loop and it will add 10, and then it's 20, so it'll go up, and it says that 20 is still less than 30, so it goes back into the loop and it adds 10, and now it's 30, so it goes back up to the top and it says 30, well, 30 is not less than 30, 30 is equal to 30. So 30, then it would break from the while loop, and then at that point you would just add 1 and you would get your answer 31. These examples are a little hard to find practical, and they are not practical at all, I can tell you that, but they are nice for understanding the concept. So what you'll find if you take a programming class is that you will get something, you'll get questions like that. You will be given an equation, and instead of solving it by hand, you have to solve it by using the program, or you will be given a program and you have to trace through and see what's happening. So that would be the reverse of what I just did. You would see the program that has it's starting at 0 and then going into the loop and then adding 1 at the end, and you would have to say what the answer is. And these are just exercises. These aren't practical uses, but these exercises help in reading the code. So when you receive some code that someone else wrote, then you can trace through and see what the code is actually doing. So I'm going to take a break for a moment and answer some of the questions I'm seeing in the chat. So I have one that is saying, how will it learn about collisions if the program is making collisions just by passing through? So it didn't necessarily need to be labeled collisions. I was just naming it collisions because that was easier in my head, and that's technically, in a hive situation, that's what you want to prevent. If you look at like a swarm of locusts, you would think that they run into each other a lot, but they don't because of their evolution. It's something to. It's actually, I believe, to do with they have a good perception of of their local environment, like very close to them. So when they get close to each other, they make a split-second decision to course correct. But in this situation, the AI doesn't necessarily know that that's what's happening. It doesn't know that these dots are running into each other or running through each other. It just knows that the score is going down. So the AI is randomly trying things to make the score not go down as much, and that in this case that's what's happening. In other cases, it wants the score to go up higher, but this fitness test has a maximum of 10,000. So like I said, it just wants the score to not go down very far. But so to answer the question, I can't necessarily ensure that the program will figure out what it needs to do, because that's kind of the thing with AI, is it is random, and it is it's kind of like I'm hoping that the program will get there, but I can't necessarily guarantee that it will, given that there's always a random chance that that something strange would happen, or some weird probability thing would happen to where the AI would get off track. But with refinement and better working, that should be something that can be revived by the AI, and I would hope that eventually I can get to that point. There are many different things I've added in, like I've explained in my stream about this AI. The AI will, if it gets stuck at a certain score for a while, it will kill the lesser parent to renew new possibility. But if you want to see more of that, check out my first stream. I see a question, I'm not sure that I understand. It says, is my AI a while loop? Okay, that's a the loop is called a while loop. That's WHILE. I'm sure that was harder for me to pronounce than to spell out. And yes, actually, there are several while loops in this program. So in the base program, the overarching AI that's controlling everything, it is a massive while loop. So what's happening is every time you see that generation number go up, then it has done everything in the while loop that it's done everything that it can in of going down the while loop, and then it starts back up at the top. And the difference, and the strange thing about the while loop I'm running here, which you'll find isn't that strange in most programs, it's just that it's strange to think about as a beginning programmer, is that there is no way for the while loop to break. It is constant. The statement at the top is literally the word true in Python. So it never is false, and so it just keeps running until I close the program, which can technically have some technicalities if I closed it in a interesting spot in the program, but there aren't that hasn't become very problematic. But then in the child programs, which is what you're seeing with the dots here on the screen, the there is another while loop. So when the AI runs the child program, it goes into a sub while loop that is running the game or the task here. So the task runs until I believe in this case there's a time limit on the task. So the program runs it runs about 5 seconds, I would say, maybe less. I think it might be 3 seconds, and then exits the while loop. And how it does that is there's a timer. So every time it runs through 100 iterations. It can actually if the computer's running a little slower, then it won't run through all of those, but it should run through 100 iterations a second. And so every time it goes through an iteration, it adds one to the timer, and when that timer hits the magic number, like I said, if it was 3 seconds, then the magic number would be 300. I don't think it's 3 seconds. I think it's a little bit longer than that. But when it hits that number, it checks up at the top with the while loop, and then the while loop is no longer the if statement is false. So the program breaks from the while loop, and it reaches the end of the program, which closes out, and that's why the next program starts. And that's why you'll see the program number there change. The reason that sometimes it will go more than once, and actually it should go more than once every single time, is because I'm simply running that program 3 times to get an average score, which is to remove the luck from the situation. I'm seeing another statement here that UF has a supercomputer. That's awesome. I'm the computer I'm running on is less than super at the moment. Like I said earlier, it was running at 100% of its CPU. So I'm sure the video is very, very choppy, but I'm hoping that the information from the audio is helping out. I know I had some suggestions that I should be bringing up the paint screen more so that I can give some visuals, and I will be attempting to do that as I can, but like I said, the program, the AI program I'm running at the moment, is eating up all of my computing power. So even a paint window, and I did test it, is kind of a little crazy, because it just takes away from the quality of the AI running in the background. But at the end of this video, I will pull it up and do another one of my more free-flowing activities like I did in the last stream. Okay, I believe the window is visible now, so I'll be doing a segment, much like the one I did in the last stream, where I'm going to pick 3 random words from my piece of paper here, using my calculator with the random number generator, and I will attempt to explain what is going on in this window here. So the first number is 1, which is a rock. The second number is 11, which is tango as the verb. And the third number is 8, which is gargantuan. So it is a gargantuan tangoing rock. So I will try to explain that. So first off, let's get a more rock-like color here. So if we have a gargantuan rock, it is going to be massive, and that is not the color I selected, but we're going to go with it. So we have this massive rock, and it is very, very rock colored. And we see that it is tangoing, so we need to have the little clappy clam things. Do not quote me on that name, it is wrong, and I'm sorry if that is very offensive to you. But the thing is, it takes 2 to tango. So this rock needs a partner, but obviously we're gonna have a girl partner, and it is a girl because girls like pink, but they are also smaller. So this gargantuan rock and its slightly smaller dancing partner here will begin to tango. That would require arms in most cases, but this is a rock, so I will assume that it does not have any appendages. I'm not even sure how the musical instruments are being attached, but we will leave that to your imagination. And I would think that if it is a massive rock, then you will see that large rocks tend to start gathering some snow on the top. I noticed that with my white background that is not very visible, but you can see it right here on the border. Also a gargantuan rock would interfere with the airflow of the situation, so we would, if the air here is flowing in this direction, then there would be a low pressure zone over here, but that would only cause the dancing partner to be forced closer to the gargantuan rock, which would in the long run be more beneficial to the tangoing, considering that it requires a more chest to chest bodily arrangement. So if they're tangoing, then we might as well put a rose here, because usually when people are tangoing in the movies, they have a flower in their mouth because that is attractive. And to complete the rose, we're going to have, well, the roses have thorns, but that's not really that big of a problem for a rock. Rocks tend to be rather solid or viscous in some cases if you consider everything a liquid. But so yeah, we have these two rocks here, and I mean, if it's really tangoing, we can assume this one probably has a mustache, and this one probably has some pretty hair, just because I like to assume that a tango dancer would be relatively attractive. But I do think that this is starting to become a finished product. And I'm getting word that this is very sexist, so let's make the dancing partner orange instead, because society requires it be so. I don't think that French drums are necessary. I don't think that would really add to the tangoing situation. That was a recommendation from the comments section. But I do think that this is a relatively finished product, so from that point on, I will just take general questions and suggestions. I see that some people were saying it would be better if I could just draw on a whiteboard. That is true in terms of my art ability, but the computing power would be actually worse to use the video camera, and which is why I haven't been having a face cam for these. I do hope to rectify the situation soon if I can get some more powerful hardware. But that being said, it is pushing on 9 o'clock and pushing on an hour on the stream. So if there are no further questions, I think I will play a final ad and close it up here. So if you have any questions, then post them in the chat, but if not, I will be closing the stream here. Alright, so I'm sorry that this stream was a little lower on the quality side. I will try to work on that in the week to come, although Christmas is going to be slightly distracting in that term, but Christmas is Christmas and we all love Christmas, so I hope you have a wonderful holidays, and I will see you in the next stream.